So now we'll move to the last section on the architecture for trust, and we'll have 3 presentations in this section. So the first one will be from Ian Wardell. He's from Seton University School of Law, and also Jun Take. He's the principal engineer at Global Government Affairs at Intel Corporate. Ian and Jun, please start with your presentation.
It's a pleasure to be here. Give me one moment to share the slides. So as you guys were just speaking about, a lot of the major issues are dealing with data transfer, and I think we may be one of those niche projects dealing with that. So as I said, it's a pleasure. My name is Ian Wardell. I'm a JD candidate at Seton Hall School of Law in New Jersey, and I have a master's in cybersecurity from Rutgers University, like some of the esteemed professors we have here who teach there. And then I did a computer science degree also at Rutgers University. And then June, who is here as well, I interned underneath June at Intel Corporation, where we worked on this project and did some significant research trying to figure out how we can make data transfer a little bit easier for you guys. So what we do know, and as many of you have pointed out ahead of us, is that artificial intelligence is often depicted negatively in the media. What this does is it creates negative views which influence the voting public, and that influences lawmakers. So what ends up happening is that policymakers often act without fully understanding the core issues behind their machine learning or artificial intelligence that we're working with. These lawmakers are generally not AI experts, and they also don't generally have the best and the brightest on hand. Those tend to work for corporations. And experts can educate and create. So the role that people who are the best and brightest in doing significant research in academia and working in corporations, they can actually work to differentiate between things like AI use and AI design, and generally be a positive influence in the AI space. So that is one of the key things that we're trying to do here. So something to note is that this relationship between the stakeholders involved are generally the public, which, as I mentioned, has this sway over lawmakers, which then has the ability to sway industry, which then turns back around and sways the public. So if you have the public with a negative view of AI, what happens is the government will regulate stronger or more strict regulation, which will then impact industry and may often produce a worse situation. Whereas if you can alleviate a lot of the public's concerns, which are generally things like fairness, privacy, transparency, and controllability, you can actually increase their perception of its uses and therefore make regulation more favorable to its use and allow industry to continue building very cool things, like, for example, the medical project. So a lot of these concerns generally tend to deal with fairness. So what we try to do is develop both a policy and a tool to actually assist with moving data sets or moving anything along through country to country and for projects. So what we did was we developed a prototype policy and technical framework tool. This means that we spent a significant amount of time doing legal research across internationally to try to figure out what is currently happening and what will be happening in the future with AI and machine learning regulation. Then we concentrated on a specific area of that, which was data transfer between countries. This is an area that is an up and coming area of regulation where we're seeing a lot of movement and where solutions are going to be needed moving forward. So our goals are to allow AI to be deployed generally for the good of society. And to do this, we need to engage with policymakers to develop fair and reasonable regulation, and then develop technology to support that regulation. The goal would be for people and companies out there to be able to develop reliable and trusted AI products and software. Well, the technical solution we came up with is data tagging. So this is something that's been around for a long time. Many of you may know the word metadata, which is data that's stored within files, pretty much anything now, and you can view it sometimes using properties or via certain command line tools. So what we're doing and what this project essentially did was take all those laws, create a database of them, and then be able to tell what the goal is to be able to tell what country and where you can move something. And this could be applied to not just geotagging, but to any area of data privacy. So how does this help? Well, it helps alleviate the consumer concerns of fairness because you can actually disclose the type of training data that you're dealing with, where biases may be, and how information is being transferred. And you could do this by reading tags off every individual piece of data. So for example, if you knew that something was consented for certain types of training, but not others, you could have that in there in your tag and then read it. And privacy, because you can actually allow, you can use only the data that you may need, or you can use it to hide the data that isn't needed. And all of this can actually be moved with the file. So one of the big things with this is that not everything out there is actually a privacy concern. So not all data has these concerns. For example, data that would be public domain data. So this data is still important to be tagged. So you could say that, hey, well, we know that this object in our data set is public domain. We're going to tag it that way. So now when we try to go to move this data set from place A to place B, you could say, okay, well, we know that 10% of this data set is movable because it's just public domain data, and maybe the rest has to be given more scrutiny, or vice versa. And what you could then do is you could allow that view of your data set to be transparent. So you could actually show this data using a dashboard, essentially where, what kind of data is being used for the training, and allow people to actually see, okay, well, we know that this medical data is movable. And that also goes into the controllability. So now you can provide people with the ability to see the data, see what it's made up of, and then control where you want it to go because you've now tagged the data. So now if you have a somebody who owns a part of that data or who has control of it under an international nationally recognized law, so say the GDPR in Europe, which covers multiple nations, and therefore they have certain rights. You can allow those people who own it to then exercise those rights and be able to see that it's actually happening. This also allows both ends to be able to deal with this a little bit better. So instead of having your data sets have to be individually reviewed, you could have users just click through and say, okay, well, it's made up of this, and I'm in these data sets. Oh, maybe I don't want to be that. I can remove it. And that opens it up to allowing the public to have a little bit more trust in the way that we're handling people's data. And then transportability. So here, this is one of the core issues we focused on in the research, and this is how you can actually move that data. So you could see overall where your compliance is. We know that with certain rules, especially between the EU and the United States, is that you can't move certain data sets without having to use these extra standard contract clauses and other GDPR compliance issues. This same issue occurs if you're moving data between countries which have adopted the European model, such as Japan. So in this case, you would want to be able to see what you can move and or not. For example, if you're developing self-driving cars and taking mapping data, you may not be able to move certain data out of Germany because Germany has laws around what you can view on the street that are not the same as public domain data in the United States, where if you took a photo on the street of any street, that would generally be shareable. In Germany, there are different rules around what is private and what is not. And you can see if you actually go to Google Maps and look at Germany, you'll find that there's no street view in most places except for landmarks. So what is a basic example of how to do this? Well, there's a developer who developed something called Exif tool. And this is an easy way on a Linux command line. And there's other versions of it with a GUI, I believe, as well, if you're on Windows, which will allow you to actually view metadata. So here you could tag it based on country, which can be done for images. Generally, you'll see this in your camera automatically tags things like this. So all you have to do with this is then, okay, it's not here. So the way this would work is you see this command line is an example of what the metadata on a normal file looks like. This is a very basic example. You can see the comment line shows optimize using EasyGIF, which is a service to optimize GIFs. To edit this, all you have to do is put an Exif tool, and we use a sharing equals true to then add on to that. Now, this example uses the default XMP format for this file type. However, you could develop your own XMP file types and apply it to your data types. So if you know you work with a certain standard of data type, you can actually develop a specific object XMP for the metadata behind that and then apply your tags with that. You can also use the defaults if you have a variety of different file types, and that way you could still pass your data with it. Now, there are some issues with this, which such as how do you make sure the data hasn't changed? Well, with that, we can use something that's been around for a long time as well, hashing and basically version control like Git. And that way, if a data set changes, you could tell by the hash changing, and then you could actually backtrack through your version control and just see what object changed and how it changed. Just like you could then apply your visualization to view your data. And the idea here is that what we're trying to do is take an existing concept and then apply that in a way that anybody can use, and that pushes the ability of people to gain trust in AI. The goal is to be able to help allow AI to be more utilized so that the adaptation of this technology is not hindered by overcompensating regulation, and that people continue to build cool and exciting projects with it, such as saving all of us building the COVID-19 application. And thank you very much. I believe that is my time.
Thank you, Ian, for the presentation. Now we'll move to the second presentation that will be by Shigeru Suzuki, the project professor at Graduate School of Media and Governance at Keio University. Tatsuya Kurosaka, professor, project associate professor at Graduate School of Media and Governance at Keio University, and also co-authored by Jun Wulai, which Jun will also be the moderator of the discussion later. So the floor is yours.
Okay. So I'd like to talk about the dependency among data code governance and operation in trust. So I'm Shigeru Suzuki, Keio University. So interesting discussion. I was the discussion in this conference is really good. But you know, the digital identity is the key component or the necessary component to realize what we are discussing here. So let me discuss a little bit about the technical detail on this. So to use a digital identity, you need to rely on a sort of the chain of reliance of related parties. So if you think about if you want to verify somebody in physically, for example, then you need to see the person. You can meet the person, but unless you know about the person, you can't verify who he is, he or she is. So you need to need to rely on somebody who can provide some proof or guarantee who is the person is, right? So the verifier relies on the sum of the guarantor to verify the subject. So for this purpose, we are using public key cryptography and the relationship among these parties. So usually, public key cryptography is used to express one-way relationship of pair of entity as a data signature. So verifier guarantee relationship can be expressed as such kind of data. So one of the standard we use is X509 PKI. And in X519 it is issuer subject relationships. So it is possible to use multiple relationship data to create so-called chain of trust or web of trust. So since you need to rely on somebody to guarantee somebody, then if you need to apply multiple, you need to rely on multiple people, possibly indirectly, to verify the subject. So you need to rely on multiple guarantors in chain to do this sort of thing. And actually, this is somewhat related to the design of the domain name system. So, and you may know about the domain name system, which is the part of your email or the website. And these names are distributed management among multiple servers. So for the KO, the KGRI side, you need to rely on at least this amount of the servers. But in reality, in some of the research done in past, mentioned that you need to rely on 40 or more servers to resolve one address in average. So you are depending on multiple servers to make your services available to somebody. So now, back on the topic of the data code governance and operation. So when I'm look at the DNS, then when resolving a DNS, it will start from the root of the domain name system, then going towards, usually if you read the domain name, the root is the rightmost part. So you need to read rightmost towards the left, separated by dot. So for the .com site, then you need to look at the DOM is referred to the com, and the com is referred to next level domain, and so on. And these are administered by different domains. So different administrator has a control over each of the domains. Then when you are looking at the X509 certificate, which is typically used in various level of the security management or digital identity realization, you verifier need to rely on the first root level domain. Then these CAs certificate authorities relying on the intermediate CA, they end up with the final end entity certificate. This chain is very similar to the domain name system, but there are multiple administrative domains exist in these situations. So what I want to say here is that data code governance and operation is applied to this controlling small amount of data. So each of the administrative domains controls small amount, very small amount of the data. For the PKI, list of the root of the CA and entity trust, that is called the trust tour, or list of certificates issued for the CAs. For example, the PCs you are using is a Windows or Mac, which has a trust store built into the operating system. So that is controlled by either Microsoft or Apple to which CAs, root CAs, the operating system want to trust or not. So the DNS list of delegated subdomains labels created in the zones as also small data. So maintaining in such kind of small data is a concern of the administration. So the policy of the small data decides operation on it, and the governance mechanism defines the policy, possibly controlled by regulation. So in certain, by the way, in certain exceptional cases, small data is tightly coupled with code. That means, for example, blockchain is intermixed between the data and the code, and that is an interesting system. So there is too much dependency and the influences among these, and so the small data with code controls the data itself, and this is controlled by operation. Then policy is applied, and the policy is controlled by the governance and policy by regulation, sort of thing. So there are too much dependencies, so we want to reduce the dependencies for various reasons. And we are observing multiple new tools lately. So one of the tool is called the verifiable credential, the other decentralized identifiers. Also, there is last year, one of the extension is proposed under in experiment status, and that will be used as a part of the realization of the shortening or the reducing amount of the dependencies. So let me skip this slide. And so summary, so too many dependencies for verifying digital identities. So the redesign seems to be inevitable. So applying a new tool might be a good way to make this better. Thank you very much.
Thank you so much for Chia's presentation. Now we'll go for the last presentation that will be by Anna Maria and the last. She's from the doctoral school on safety and security sciences of Wardell University, and which is co-authored by together with Andres Curti. Anna Marina, the floor is yours.
Thank you so much. Good morning for everyone. As Sherry said, my name is Ana Maria de Guambelas, and I'm a PhD candidate right now in Hungary. I have a background in public administration science and law, and my doctoral research focuses on information security of the governmental sector. And my research partner, Dr. András Kerti, sadly, he couldn't join us today. He has an extensive knowledge in information security in the defense sector in the military perspective. Our research is a new approach to the information security auditing in the public administration. Auditing in the governmental sector is a very niche topic compared to those what we have discussed today. But why is it important, and how does it connect to cyber civilization, you might ask? In the previous presentations, we talked about trust, physical and digital identities, privacy, and government in general. How does the auditing connect to architecture of trust? First, we have to take a look on public sector in general. What is the use of public administration? The primary mission of the public administration institution is to realize public tasks in numerous fields. For example, social security, local waste, roadworks and constructions, clear water usage, or public administration just generally issues permits as well. With the modernization of the state, these essential functions are constantly extended and differentiated. But what lies in the core of public administration mission? How can public servants, after all, make any kind of decision? Well, they need information. According to Herbert Simon, who is a theorist in the public administration science, These institutions are carrying out their task by finding the best decisions based on the available information. Decision making in an institution is realized by processing an information, an input information, into an output information. An example of this process is described by the issuance of administrative decision, for example, a license card. The input data here are documents which are provided by the citizen. For example, proof of residency, proof of age, a certificate of a driver's education course. And what is the output data? The output data is the issued license. So we can boldly state that the functioning of public administration is based on gathering, processing, transmitting, storing, and sharing information. Therefore, information is one of the fundamental assets, and it's considered a protected value. Since information is such a crucial element in the public administration, if there is any kind of security incident that can even disrupt the whole functioning of not just the public administration system, but the whole governmental system in total. I think we established in our research very well that we always have to make sure that public administration runs effectively, efficiently, and securely. And security. Here comes the auditing. In order to support the public administration, we have to audit it and always make sure that public administration systems are secured. In our research, we analyzed the different public administration auditing processes. Auditing itself is a complex notion. I'm sure those who are here, you heard about auditing before, but just a brief definition, it's a management tool that evaluates organizations' performance and determines if the criteria for the activities are met. Through auditing, we're analyzing if the institution we are analyzing is measured to a certain status. Without going into too many details, let's consider the two major audit types. Those are the internal and the third-party audits. What are they? The internal audit is basically a self-monitoring. In an organization, at least one employee works as an auditor. This person is responsible for planning the audit, gathering the information, scrutinizing the organization processes and procedures, and also making a report on them. But what is the problem with internal audits? Literature review and our research evidence shows that people have great difficulty in identifying and correcting errors in systems that they created themselves. What it means for public administration, those who are working there, they might find it really difficult to correct errors what they made. And also, people tend to hide information. Many occasions, auditors in the public administration sector, they only said what they told their audience wants to hear or ready to hear. This means that many times they hide crucial information about security breaches. In contrary, we can look at third-party auditing. Third-party auditors are completely independent from the auditee organization. So we can say that they would be able to find, identify, and correct errors. And also they will show the real problems. But third-party auditing in the public administration has many concerns. For example, public administration institutions have to trust this new identity, which is outside from the public administration. And also the recommendations from third-party auditors are not obligatory. Therefore, the organization has no legal responsibility to act on them. And also, third-party auditors can be really expensive. So the solution we came up with is the adoption of a new approach by establishment of the so-called Autonomous Public Auditing Agency. This agency would be an institution within the public administration system established by the government. its goal is to overview and strengthen the information security system in the public sector by conducting regular audits. And there are some specifications of this agency. For example, the central government budget finances it. Therefore, all public entities would be able to participate in the audit programs irrespective of their financial status. Secondly, the personnel of this institution would make up by public servants who are able to have the necessary regulatory and also technical expertise. And thirdly, the audit report, what this agency would make, contain the analysis of the errors, identifying the problems, and also accompanied by a set of controls required to reduce risk to a satisfactory level. If someone fails to implement these controls, they can conclude in receiving a fine. In conclusion, we established that information security management and auditing in the public administration is a fact, the realization of public trust. Information security auditing is a complex process and it requires good knowledge, understanding of the public administration, internal and external environment, and its structure in systems and processes. And therefore, we need a new approach to be adopted, which can achieve efficient, effective, and economical answers to information security threats.
Thank you so much for Anna Maria's presentation. Now we invite Professor Mulai to give to lead the discussion, and we invite other authors of this session to join the discussion.
Okay. Yeah, thank you very much for all the excellent presentation overview. And so, basically, because of the limited time, then, each of you presented the very important points about the, kind of data in the data system and the other thing. So my question is basically, the roughly is the same. So, it's about the context and the domain, of the, how to handle the data, because, you are talking about the, some Ian and Shigeya talked about the system itself, which seems to be, kind of applying to the kind of general data handling. And then, Anna Maria talked about the public administration, and then, also probably the background is going to be a, kind of a national security issue in a kind of public context and public domain, right? I mean, public, space. So I was thinking, especially, I've been working in this country, and I also agreed with Anna Maria that, we should work starting from the very much, kind of a domain where the definition about the auditing and the law and the rules are pretty much fixed, and therefore the handling of the data could be defined easier, right? And so probably what Anna Maria was talking about is kind of that kind of area. Thank you very much. And so my question to you is that how that general purpose, data era, right? So, data use for the commercial purposes, medical purposes, and any domains in, that's a future and maybe today. So do you think that extending beyond the border of, kind of public administration to the other area, and what's going to be the difficulty on that?
Thank you very much for your question. Data usage is very important, I do think, in many countries, and making the right policies. And Ian was also talking about it, making these policies of data transmission, sharing it, and usage is really hard. And I do think that we do have to protect all the systems which are using data, all those systems which are gather and transmit these data, but to share it with the private sector, with the economy, is a very hard question. I do believe in every single country, because for to do that, we first need to have policies and we need to have really harsh regulations. As much as I do believe in that, I do believe in laws and policies and regulations, and for it to be secure and useful, we do have to create for that. And right now in Hungary, the government is making efforts to create new policies and strategies, for example, to data sharing. And they just adopted a new strategy last week, which allows governmental gathered data used by private sector. And I do think it's a very good initiative. Many countries, for example, the UK, they already been doing it for many years now, sharing gathered data with the private sector and help the economy to gain more knowledge and figure out new solutions. But I do think to share data internationally is really hard, since the new data protection rules, what Ian was talking about, and the transmission rules. So I do believe if, for example, Hungary wants to share its information with Japan, they would need a special agreement and systems and policies figured out first.
Also, what you're saying is that a specific domain type of a thing, right? Okay. Yeah. Ian, you mentioned and you discussed, the kind of a general type of kind of policy, data, and the privacy and other things. So, what about the context of using that kind of a data? Is that applying to, what you're thinking and what you're proposing, or can you think about the kind of independent from the context and the domain, and then you can create a certain framework or anything generally could be applied to any kind of a context, any kind of a domain. What do you think about that?
So first, let me start by saying that I can second the idea that, for example, a lot of countries are still working on their data law. I know, especially in the absence of the Schrems II decision, which throughout the US-EU privacy framework, everything now for those transfers needs to be done on the SCCs with supplemental, and those were just released last year, I believe, effectively. So there's a huge new area of the data privacy, especially for cross-border dataset transfer. So if you're going to move your machine learning data, basically, which is king right now, across borders, you have to worry about that, especially if you're not in the EU. And I know Japan relatively recently negotiated their adequacy status with the EU, and that is, again, very recent as well. So what we're seeing is a lot of development in the regulatory space continuing, and that there isn't really a general standardization yet of that happening, and there probably won't be in the next 5 years if I had to make an educated statement on that. As far as the issues that you're all bringing up, which are extremely valid, the idea and something I was trying to bring up in our research is that you can develop a tool to actually see what the status of those regulations are, both currently and moving forward. You just have to maintain this database of law, which would probably need to be done by an attorney or somebody who can take the liability, basically. And I come from a security background, a hard technical security background, so security engineering, security research. And a lot of what I envisioned a tool to do would be a lot like you would watch firewall traffic, where you could, because that data moves so quickly that there's no way that you could have a human monitor it. And that is very, very similar to real-time data movement if you were, say, running a self-driving system. So what you could do is you can real-time tag it and then deal with the anomalies. And that would allow you to then come up with percentages and visualizations for what you can and can't do. And that means that you can have people who are probably not attorneys and spend less time to view what can and can't be moved. And I think that's really a way to push forward all this data. I feel free to come up with a follow-up question. I am more than happy.
Okay, yeah, thank you very much. I think that's a great point. And Takei-san, you are co-author of the paper, and then so also we just finished kind of a session of the medical data, medical domain type of things. And don't you think that kind of when we are working on a kind of medical data, and then like Anna Maria talking about the kind of public administration. I mean, can we mix? I mean, generally proposing the solution of the system for the kind of a multiple domains or the domain specific?
I think we cannot separate the domains. So, for example, to improve the medical care or medical service, they means medical doctors, they want to see the personal behavior.
Okay.
What kind of exercise or how do they walk or how do they stand in the day? That information helps the doctor a lot. But these days, that is not the medical, that categorized as the medical information. And also, for example, the traffic information on the train or traffic information on the highway. I think the Department of Transportation, they just say that is the traffic information and it can be public. But the defense ministry, defense organization, sometimes they say, oh, that is type of the national security data, so you cannot share it. So today's discussion started from Mike's list of the questions. That gives a lot of interesting topic and a lot of challenges in front of us. I'm sorry, I don't have answer today, but I think we have to assume that we cannot distinguish this data is national security, this data is personal health data, this data is something different. It is very difficult to draw the line between that kind of types. So we have to think about the architecture, like the Saito-san mentioned, architecture or operating system that can accept variety of different category or variety of different requirement. I think that's what I heard in the session.
Okay, so it's an interesting discussion that Shigeru-san, you mentioned about the architecture and also the the DNS and the other things and the trust and the ideas, which has been discussed for the the operating systems we've been working on right today. And so my question to you is that when the internet was there, it was like a kind of more to the IP thing, right? I mean, internet protocol, this IP is, and then so basically the all other things has been called over the top, right? So over the top, you can do anything. It's a free, and so now when you are talking about the kind of privacy and the data use and the protection and the encryption and the other thing, on the architecture, is that going to be the kind of platform side or the application side, which is very similar to the kind of domain and the context questions about the data architecture? So from an architecture point of view, what do you think?
From architecture point of view, of course, long ago, I was thinking about whether it is possible to create some sort of the platform to do generic support of anything sort of thing. But as Takei-san mentioned about it, we need to remove the borders. I mean, the domains. We can't fit everything into the every pieces of information into the separated domains. I mean, we do not want to have some sort of the partitions among these domains. So from that point of view, of course, we need some sort of the generic platform, but it seems to be very, very difficult when we are looking at, for example, if we are looking at the RFID technologies, every area, every domain has some sort of the vocabulary to do things. And that vocabulary is different among these domains. So we need to find out a way to express both the domain specific thing and also we need to remove these partitions. So that is challenging, and really wondering which way, I mean, the application way or platform way, which is better, is still I'm thinking about it, going back and forth on which is better at this moment.
Okay.
Yeah.
Thank you very much. Kurosaka-san, you've been involved on kind of and supporting the other government activities of Japan regarding the kind of a data area. So from that point of view, then how you think you should approach to the the thing. So basically the question is the same. So is you wanna work from the specific area to achieve the implementation design of the architecture and then extending to the other parts, or you wanna kind of design the the general platform first and then applying to the kind of national missions of data architecture.
Yeah, thank you, Jun. Then it's very hard to make clear answers because it's very difficult questions. But I think on the basis, the subject of the data protection as well as security and trust is to make an ordinary communication correctly. And this time we don't share the context of correctness. Some people say the correct is depending on the adequacy, and some people say the integrity and authenticity as well. So that's why the government, this is a very important and very difficult role this time, because the architecture will be changed. But our government should lead to make the consensus of the kind of communications. So that's why it's very important to enable verifications as a communication depending on each context, each business areas, and each purpose as well. So the government, especially the Japanese government, is now trying to see the opportunity to make a arrangement between each industries and also the citizen side and also the government, the public areas and something. So we now looking forward to make a new consensus of the context of the trust, including authenticity, integrity, and adequacy as well.
Okay, thank you very much. I think we are almost running out of the time, and therefore I'd like to ask the last question to the three speakers who did the presentation. Well, what's going to be the what should be the next action on this area from your point of view? So starting from Jan.
I think that one of the next actions should be to figure out what a set standard is for actually moving these and coming up with tools to make that possible for the everyday developer or person trying to use this technology. It's very fragmented right now, and the coming up with a status quo and actually a way for people to put this in their technology would move, I think, the field forward generally quite a bit.
Okay, yeah, that's great. How much time do we need for that action?
I think it depends on how much effort we put into it. As we know, within the past year, we came up with a vaccine for a virus that we thought would take years, and we did it in 6 to 8 months. I think with enough effort, we can do anything extremely quickly.
Oh, that's great comments. I like it. Okay, Shigeru-san, the same question.
It's hard to question, but maybe we need to do to start with a real pilot. I mean, useful thing. So just not a toy. I mean, so like mentioned, Ian mentioned about the vaccine, and that we have a real urgent use case. So that is a good topic to discuss about, I think. And that is the first thing. So we need to get together both the technology side and also on the policy side. Everybody need to get together to think about this urgent topic.
Okay, thank you very much. Anna Maria, you have a kind of a specific area so that your action and the timeline you're thinking about that kind of action might be a little bit different. And so this is the last question to you, Anna Maria.
Yes, as much as I do love what Ian said, and I would support and be very happy if the nations would be able to come up with a solution so quick, I don't believe it's gonna be happening so fast as we would love it, because as much as it's beautiful that every different country and every different nation has a different thinking pattern, it is a very big stumbling block in the road of coming up to decisions and the same projects and plans. So I do think it's gonna be a much longer time until these different nations are coming together and actually start with setting definition, as Mr. Suzuki was talking about different definitions. We need to just first find the definitions which are common and understandable to everyone, and then we can, I do think, work across in tiny, small steps, small projects, very technical ones, and hopefully in the long run we will achieve that goal of having a unified law and unified standard.
Okay, thank you very much. I think we have time limits, and so thank you very much again for all the presentation in this session, and I'm going to give a microphone to Cherry.
So we are now about to conclude the event, and then we will invite Professor Mulai again for the closing remarks.
Okay. Yes. Okay. Thank you, Cherry, and thank you very much for all the people participating in this conference. And I think cyber civilization and its related technology just kind of changing all the semantic and well, basically changing everything almost as a civilization context. So we all know that, and then especially the historical experience is all we have as a COVID-19, and then that's going to be kind of emphasizing the impact of the cyber civilization type of environment. And also the important thing is that during the discussion we shared all the kind of a learning of the technology for the kind of cyber civilization area from the various segments and the policymaker leaders and other things. So it's also accelerated during the historical experiences of COVID-19 as well. Therefore, the CCRC activity is going to be and the research collection is going to be a very important one, because it's a very historically understanding, and also the sharing of the new technology coming, and also the diversity of studies working together. So it's a very important opportunity, and thank you again. Thank you very much again for that. Your diversity of very strong wisdom working together for the conference. So thank you very much.